Okay, so let's go ahead and start with a quick little review last time. Last time we learned how to define classes. And when we're defining classes, we're doing a certain type of programming. Does anyone remember what type of programming we were doing? Sometimes it's shortened to be OO. It's for object-oriented programming. A class is simply an object. And then what we have right here is a slide that essentially is that kind of talks about all of the different things that we introduced last time. So again, remember that class is a keyword that essentially allows us to create our own class. We didn't create an animal class last time, but after class follows the name of the class. This is what we're going to get a little bit more into today. We just left it blank last time, if you remember. Today we're going to talk about inheritance. And of course, if you talk about inheritance, you think about parents and children. So again, a parent could have a child class that inherits properties of the parent. So that's the big thing from today. And then, of course, we have this dunder method, which is a special method. And again, remember, a method is simply a what? It's a function. Remember that a method is simply a function, which the def keyword probably indicates that as well. It is a function that belongs or is tied to a specific class. And then, of course, the self is a keyword that allows us to pass around data between different methods and attributes of the class. This age right here is like the parameter that you would pass in as you create it. So this animal takes a parameter that is age, and then of course remember that age is then binded to a specific attribute using this self dot attribute notation. So then when we call the class with the parameters, this is of course known as instantiation. So we create an instance of the class and store it in a variable. Wow, there's a lot of terminology, isn't there? But anyway, we're going to go ahead and practice a little bit more with object-oriented programming. And we'll learn specifically about inheritance today. So just to kind of pick up right where we left off, I'm going to go ahead and work with the card class a little bit more. Alejandro, can you grab the lights, or at least the front lights for me? Thank you. So are you all ready, or y'all found where we left off? Let's switch the other ones. That's better. Oh, I could take a nap now. Just kidding. All right. So at the end of last class, we had this little exercise that you paired up and worked on, and you created an odometer, and you set its initial value to 0. And then what we have right here is we created a method that allows you to go ahead and set the actual odometer's value. This is sometimes referred to as a setter. Did anyone have any follow-up questions from that, or did you all kind of get that before you left last class? Okay, everyone's good? All right, so if you look at what we're doing, this is kind of weird. Down here below, when we want to go ahead and get the odometer reading, we get access to the attribute. And then when we want to set it, we call a method. So it's a little bit weird to do one thing one way and then another the other way. So again, a common paradigm would be to define the setter, but also to go ahead and define a getter. So GET, and then we'll just do underscore odometer and self. And again, if you think about, we don't need an argument for this method because we just want to get whatever the attribute is. So all we're going to do is just return whatever self.odometer is currently reading. So again, this is actually not strictly enforced in Python. Like you can actually go ahead and access the attributes specifically, but just it's actually pretty bad practice because in some languages don't even let you access the attributes. You need a specific getter and setter method. So again, we had the setter above, and here we've defined the getter. Getter, that's a fun word. So again, if we do this now, what we could then modify is the access to my first car, and then instead of just getting the attribute, let's go ahead and get the attribute by using the method that accesses it safely. So that's so this allows us to go ahead and program a little bit more consistently, that we access the attributes through methods. So really the only thing you'll ever do with that dot notation is call methods, instead of sometimes calling methods, sometimes getting attributes. So that's just kind of a nice programming paradigm. That's good to keep in mind. All right, so let's go ahead and run this and make sure everything's still, So we have our 1994 Chevy Lumina. We have this special dunder method that essentially gives us the string representation that we want for our class, and then we have this setter and getter. Any questions so far? Okay, so here's another advantage to using this getter and setter methodology. So like when you're defining a class, it's maybe to be used by another part of the program, or if you're on a team to maybe modularize the work. But if you think about an odometer, you don't actually ever want negative miles on the car. That would be very dishonest if somehow the manufacturer said, "Ooh, we're gonna set the odometer to negative 100." So like if you think you're getting a new car, it says 0, but it's already been used. So the good part, we can actually go ahead and add some logic in here to go ahead and set the when we set the odometer, maybe we want to make sure that the mileage is actually appropriate for the objects, or in this case the odometer. So if the mileage is greater than or equal to 0, that's when we'll go ahead and set the mileage. Else what we can go ahead and do is just we can just go ahead and kind of print a warning if we want, and just say something like you can't have negative mileage, or something like that. So now if you try to set the odometer to -1, you can see right here it's going to say you can't have negative mileage. So it allows us to do a certain type of checking. All right. So now that we're just kind of getting warmed back up right here, let's see. Any questions so far? Yeah, Anna.
Why are we setting and getting instead of, like, what's the point in setting and getting instead of just doing what we're doing?
So the main thing is, well, in Python it doesn't strictly enforce it. So again, in general, I'm just trying to teach you general programming patterns as well. Should you ever need to learn another language like Java or C#, they're very picky. They're like, we don't want you touching this attribute. They actually even have private attributes that like if you're instantiating it down here, you won't even be able to touch it unless if the programmer of the class has defined some interface, that is to say some method that allows you to do it. So what's the difference is basically I'm just kind of adding this extra layer to kind of show you this paradigm.
Okay, cool.
Can you still do it? Yes, but I'm going to encourage good practice when I can. So, so there's where we're at with that. Let's see. Anything else I want to go ahead and do right here? Let's go ahead and just say, let's go ahead and maybe just a little bit of exercise to get you warmed back up. Let's say write a method that increments the odometer. So let's say that you take a little trip and you want to go ahead and say like, oh, okay, the software needs to kind of update this, and of course this is obviously a very contrived example because as the wheels turn is when the odometers, but just a little exercise, write a method that increments the odometer. How would you go ahead and do that? You can, I'll leave it up to you. I'll give you maybe a minute or two just to think about this, to kind of look at where we're at in case you didn't looked over it the last 2 days. Get your mind back into it. All right. So, just getting ready for where we're going with next. All right, so there's a couple ways to go ahead and do this. I'm going to just go ahead and define, we'll just call this increment odometer. Did you guys choose to pass in a parameter, or did you guys just do, you chose to do a parameter. What was the parameter?
I did self and index.
Yeah, that's a good thing that you remembered self, because if we're going to adjust the attribute, we do need this function to have access to self. And what'd you call it?
Index.
Index, okay. That's fine. So then what did you do right there, Anna?
I returned index plus self dot odometer.
Okay, so if you returned index, what'd you do?
Index
Plus
self dot.
odometer. Okay, so this is good. This actually increments it, but does it actually ever adjust the attribute? So if you're to do this, remember that you still want to go ahead and actually adjust the attribute as well. So you can do self dot odometer plus equal to whatever the index was. And then again, you may actually even choose for it just to not even say anything. Maybe like if you kind of think about what this is doing, you just kind of thinking about this. This is like, okay, increment odometer, the only thing I want it to do is increment the odometer. I don't necessarily want it to return anything. I don't know. So again, you have some options on how you want to do it, but that's just maybe a little bit of thought as I go through it. So maybe you want to, or you could have said return, and you could return like the string, let's do an F string. The odometer is now at, and then you would just, because you updated earlier, you would just do something like this. So maybe just kind of providing some feedback to the caller of what it actually did. And again, that's just some feedback, just kind of some thoughts that I had. But anyway, everyone have something similar to that, or anyone have any follow-up questions? Okay. So the next thing I want to do, if we're driving, and this is just to kind of get us ready, let's go ahead and define another function. How many of you have your own car down here? A couple of you. How many don't want to drive it because gas is like $4.20 a gallon? It is painful. But it's just to kind of get you thinking. Let's say, okay, something you got to do with a car is you got to fill the gas tank. And it doesn't need any additional parameters, but there's a couple of things you can do. Let's go ahead and define another attribute and call it self dot gas level, and let's say it's at 100%. Let's just I don't know. This is kind of up to you how you want to do that, but let's just make it 100%. So I'll do that. So what we want to do when we fill the gas tank, we want to make sure self dot gas level is now back up to 100%. And again, obviously we're kind of not giving the option to fill up half a gas tank. We're just going to say you're fill it up. And then let's go ahead and just go and print that we now have a full gas tank. The gas tank is full, and the wallet is empty. So we've just printed out a little bit of a user, or kind of some feedback. But everyone understand what, not gas rank, but gas tank. Sorry, sometimes when I talk, my fingers do something different than what I'm saying. So fill gas tank. Everyone understands what this function does. And again, if you want to call it down here, let's go ahead, my first car dot fill gas tank, and you can go ahead and you can see right there the tank is full. The gas tank. Words are hard. Got it. The gas tank is full and the wallet is empty. Sad day. All right. So I have to be honest. Like, my dream car is like a Tesla. I was like, hey Becky, 40th birthday present 7 years down the road. And I was just like, while you guys were doing that exercise, I was like, oh, how much are the Model 3s costing right now? And so again, my dream car is Tesla Model 3. I don't really care which one. I think Tesla is cool. Probably because that's something to do with my last name. I don't know. What are your dream cars? Does anyone else have a dream car? Or you're like, just as long as it gets me to A to B. Exactly.
Yeah.
Okay, but the reason I bring this up is because if you think about this Tesla, it's a car, but more specifically, it's an electric car. So it has a lot of properties about a car, but it has some extra features that are specific to that. Does it have a gas tank? If you guys don't know, it does not. So it seems like some methods aren't going to actually apply. So this is a more specific type of car. So it's kind of like that same it's like a square is a rectangle, but a rectangle, hold on. Square is a rectangle, but a rectangle is not a square. So it's that same kind of thing. You can have like a hierarchy or an inheritance of properties. So that may be a fun little exercise. I'll maybe get some exercises next week just for y'all to practice these a little bit more. So let's go ahead and talk about inheritance a little bit. So we'll just keep going with this car example. And what I'm going to go ahead and do is I'm going to define a new class. So we're going to now talk about inheritance. So inheritance. So what I'm going to do now is I'm going to define a new class. So I'm going to use the class keyword. And this time I'm going to call it electric car. And in parentheses, instead of it being empty, I'm going to pass in a car. So essentially, when you define this class, it's going to get this car passed into it. And this car is, again, just a reference to the class defined up here. So again, what we have right here is we can say that the electric car is a child of car, and vice versa. The car is a parent of the electric car. Okay, so there are a few things that are going to happen with this one. So we will again have some sort of init method. So we'll define init, dunder init. And what we're going to do is we want it to have a similar kind of setup to the one we have up here. So let's see, we're going to need make, model, and year. So I'm going to have self, of course. Then we have make, model, and year. But all of this kind of just is the same thing that you would have from a parent class. So this is where it's going to be a little bit weird at first. We're going to use the word super. Super stands for super class, so something greater. So like you have subsets, you have supersets. The greater class, is the one that's more general, is car. So it is a function. And what I'm going to do is it's going to get me the parent class. And what I really want to do is call the init method of the parent class. So I'm going to do init of make, model, and year. So I'm going to comment this out for now, just so. And let's just start with this. Let's just I'm going to call it my Tesla, maybe one day, and I'm going to create or instantiate an electric car. And what I'm going to go ahead and do is, let's say the make is a Tesla. It is going to be, let's see, I wanted I'll take the model, I don't know, Model 3, Model S. Model 3, I like the Model 3. And let's just say it's a little bit used, that's fine. We'll let some of the depreciation disappear. So I'm going to go ahead and define, let's say 2020. And what I'm going to go ahead and do is I'm going to print my Tesla, and let's see what happens. So notice, I'll give everyone a moment to type and to run and just to kind of see what's going on. Notice that what printed was not that weird kind of unformatted text, but the exact string that we defined up in the parent class. So what happened is when we passed in car, essentially all of these, without even explicitly typing them, came right down. So that's one of those things like, you know what, it's going to be able to, let's go ahead and set the odometer. So let's go ahead and my Tesla, just to see how some of this works, let's go ahead and we'll just get the odometer, and of course that will return it, so we need to print this. So if we run this now, you can see we did not define this method in the child. It just came right down from the parent. And again, we also needed to initialize the parent. So we did that by calling super, and then the super is the parent, and we initialized all of that using the parents init method. So does everyone understand kind of how this stuff just came down to the child? Okay, but if you think about an electric car, it doesn't have a gas tank. It has a battery. So what we're going to probably want to do right here is create self, and let's go ahead and call it battery level. And we can set that to 100 right there or something like that. And let's go ahead and do a little change. Maybe just to illustrate let's say if we say my Tesla.fill gas tank, if you think about that, it doesn't have a gas tank, so it shouldn't say the gas tank is full. What it should go ahead and do is say something like, there is no gas tank, please charge the battery, or something like that. So what you could do is redefine or overwrite the previous functionality. So like fill gas tank, and let's just go ahead and print to the user, an electric car doesn't have a gas tank, charge the battery instead, or something like that. But you can see like we can modify the children's specific behavior, and then of course we can define something like define charge battery self, and then that's where you would go ahead and do something similar, like self.battery level is now equal to 100%, and then go ahead and just return, or just go ahead and print like the battery is charged. Room. Okay, I don't know. All right, so now if you run this, and you can see an electric car does not have a gas tank, charge the battery instead. So let's go ahead and just say, okay, let's go ahead and charge the battery. You can now run this. I've changed this to charge the battery. The battery is charged, vroom, and maybe just for a quick sanity check, let's uncomment this. And if you were to do like my first car.charge battery, well, you can even see right now it's not auto-filling that, or auto-completing that. So it's because the parent does not actually have that charge battery method. So it's one of those things, just because the child does something doesn't mean it goes up to the parent. Yeah, Anna.
Why is there a non-return?
Say again?
Why is there a return?
Why is there a none returned right here? Because I chose to charge battery, click print. So when you're clicking, because remember, every function, aka or method, always has a return value. That return value is none. So again, you can always go ahead and do that. So
Because you had a function.
that did not have a return, and then it always returns. So,
I'm sorry.
Yeah.
If we don't put a return function and you put like print something, that replaces the need to return none?
No, it will still default to returning none. So you could have, if you wanted to, like charge battery, like if you wanted to leave the print statement there, I could have changed this to like return, and then it's returning that string. So if I print, go on, Anna.
When you're filling the gas tank, I don't have a return statement. Oh yeah, but it does.
Yeah, there always is a return none if nothing's specified.
So would you say it would be better to return a string?
It depends on what you want it to do. I mean, it's one of those things like, I meant to call this charge battery. My typing is terrible today, but that's okay, I'm sorry. Charge battery. So I guess what I would probably say right here, I would probably just print the action and return none, because what is this method supposed to do? It's supposed to set the battery level to 100%. This really, I honestly just put here to like kind of tell us what's happening. like if I were dealing with maybe a larger project, I would probably not even like print. I would maybe be like, I would maybe return like 1 for success and document this like if I am writing like some software that is actually running the car, I may want it to return something that informs the larger program that it was either successful or not.
Okay. I see. Okay.
So like then what you could do is like then I would say if my first car dot charge battery like charge, not first car, that one, print. So then you could check, like you can do like checking, like what if the battery was not charged, like what if the charging station was faulty, so something like that. So it allows you it to fit to maybe in a larger thing. So yeah, that was a very long-winded answer. But I hope it helped. Any other questions? Okay, so let's see. Just to, we haven't done an exercise in a few minutes. Let me find an exercise for you. I had one right here. So let's go back to our restaurant class right here. Let's go ahead and just as a little bit of an exercise, remember that let's just remember what this does. So a restaurant is a class that has a restaurant name and it has a food type. So if we go ahead and it was very disappointing last night, a little story. I wanted ice cream. So we went to an ice cream place called Andy's. And right before we got there, a minivan pulled in front of us. And like 8 grown men got out of this minivan. I don't know how 8 grown men fit in the minivan, but of course, since they were there before us, they got in line before us, and we had to get to the grocery store before it closed. And so I was like, we're not going to make it if we wait for these 8 grown men to get their ice cream and then me get my ice cream. So we left. Anyway, sad story. Leads into the exercise a little bit. So what I want you to go ahead and do is a little bit of an exercise. Is to go ahead and basically let me just do. Okay, this is long, so let me just kind of pull it up. But you're going to write a child class called Ice Cream Shop. So let me go ahead and just kind of get it started, and I'll pull up kind of the full exercise. So write a class called Ice Cream Stand that inherits from our restaurant class from above. So restaurant, and let me just pull up the rest. There's a few more kind of things that I'd recommend to do here. So let's pull that up really quick. All right, here it is. So let me just copy and paste this over. All right, an ice cream stand is a specific kind of restaurant. Write a class called ice cream stand that inherits from the restaurant class you wrote earlier. Add an attribute called flavors that stores a list of ice cream flavors. Write a method that displays these flavors and create an instance of ice cream stand and call this method. So go ahead and take a moment and see if you can do this little exercise right here. up on the screen, I put my implementation of this ice cream stand class that inherits from restaurant. So let's go ahead and just kind of look through here a couple things that I did, see if you did something similar, just to see how things played out. So the ice cream stand, of course, is a more specific type of restaurant. So it's going to inherit from the restaurant class. So things like we're going to be able to check if it's open. We should be able to describe its restaurant and things like that. But if you think about, we're actually, an ice cream shop shouldn't serve pizza. If it's a really good ice cream shop, just let that be their claim to fame. So if you look at this, the init method, I'm going to have a default restaurant type already built in, because you shouldn't, if someone is going to instantiate an ice cream shop, so let's go ahead and do that. Say my ice cream shop or stand, whatever you want to call it, is a instance of ice cream stand. You shouldn't have to tell it that that it serves ice cream. Like, it's kind of implied. So that's what I did right here by providing this default argument. And then what we can go ahead and do is, I wanted to go to Andy's last night, so we'll just call, if you remember, the other parameter that it takes is the restaurant name. So you can see that's what's going to be the only argument when you instantiate this class. So let's go ahead and just call my ice cream stand, and again, remember there was a method we wrote called describe restaurant. So we'll just go ahead and describe that restaurant. You can see that inherited, because we're in restaurant.py, remember I'll have to go ahead and just do this from Python and restaurant.py. So you can see Andy's serves ice cream. It's doing some weird things with title case, and we talked about that a little bit last time. So again, ignore that little weird thing going on right there. That's probably so I don't have copyright infringement, because that's Andy's and this is my ice cream stand, whatever. A couple other things to see right here. So this is me essentially initializing the superclasses init, but with the restaurant type that is defined by default by the child class. I have some default flavors already right here. And you can see, you probably, if you want to display the flavors a little bit better, so you can see my ice cream stand, and I wrote this method called display flavors that does sorry, I have to go back to the shell. Does a little bit more fancy printing right there. So you can see that it prints the available flavors are, and then you have a tab, which is that forward or \T, and then we just print them. So does anyone have any questions or any follow-up? That was my implementation. Of course, yours might differ slightly, but just some things that I did. Any questions on that one? Okay. So the last thing I want to talk about when it comes to working with classes, and it's, again, classes are really nice. So I'm going to, by the way, I'm going to go back to my car example in main.py just to work with this. Let's think about this electric car a little bit more. I mean, if it's an electric car, probably the most thing about the electric car is, the battery. If it doesn't have a battery, it's not going anywhere. It's just a big piece of metal. So the battery probably has a lot of information concerning it. So what you can go ahead and do is actually treat the battery you can treat classes as attributes to other classes. Okay, so what do I mean by that? It would be nice if I could essentially go ahead and refactor all of this information about batteries into just the battery. So let's call it self.battery is going to be an instance of a battery class that I can define. So yes, you have children of classes, but what I want to then go ahead and do is, let's say we have another class called battery, and then we can basically store all that information about the battery within its own class. It is not going to inherit anything. It's just going to be another class that essentially acts as a container for the information we want. So let's just define a class called battery. Of course, a battery is going to have like an init method. So we'll init with self. So notice here, when you instantiate an electric car, you instantiate within the init method of the electric car a battery. So let's think about some things that would be in a battery. So, so what do we call it? Battery. We could maybe do like self, and then we can say like, I called it battery size earlier, but I think we on my notes, but I think we called it battery level is starting at 100%. Maybe you also want to go ahead and let's say we have we want to query the battery, how long it'll take. So let's say we have some sort of method that says like get range or get miles to empty. I just kind of playing with this idea a little bit. So if we have a method called get miles to empty, we want to go ahead and maybe check on how far we have to go or how much farther we can go at a certain battery level. So let's say if the self.battery level is let's say greater than, I don't know, let's have just an arbitrary cutoff, 70%. You can go ahead and just tell the user, you can go far. I'm not going to do specific numbers here on a Friday, but then you could have some other like elif. Let's say it's between 30 and self.battery level is less than or equal to 70. We'll just say print, you can go, I don't know, kind of far. And then does everyone see what this method is doing? And then the last one would be else, print, you want to tell the user you should find a charging station ASAP. So you can see right here, we can kind of encapsulate this logic that is just really about the battery. The tires don't need to know about the battery, and you can define things specific to that. So let's go ahead and maybe just take this idea. Then what you can do, how would we change the battery level? So of course, if we now have this encapsulated into its own class, we no longer have battery level. How would you change charge battery? Any ideas? So, of course, because we are now basically using a class to store all the information about the battery, how would I go ahead and charge the battery level? Because again, I just commented out this self.battery level because we want that basically stored inside the battery class. So if the car wanted to charge the battery, how would it do that? If we didn't want to change the location of this method. We don't need to return anything. You're on the right track we need to go ahead and, we wouldn't say call, but we would access charge battery, or we would access battery.
So would we access self?
Yep, so you would do self dot, I need to get rid of that. So self dot battery, and then what would we do? Anyone? When in doubt, you could always hit dot. And again, what you would need to do here is access the battery level of the battery and then set that to 100. Again, this is kind of ignoring our discussion about getters and setters from earlier. You would maybe have like a setter or something down here and things like that. So, yeah?
So are you referring to the class battery and then the method battery level?
Okay, so this self allows me to access the init methods. I get the battery of self, which is an instance of battery, and then this is the attribute, and you can even see why this feels a little weird, which is maybe why you would then want to be like you may want to define like a set battery right here, and then do something like self, and then some n, and then you could go ahead and just do self.battery level. battery level is plus equal to n, or is equal to n. That's what I'm doing here. And then it would be a little bit more obvious, because then you could do is call the set battery, passing it in like 100 or something. So this might be another way to do it, but using just the getter and setter, or the setter idea. But yeah, so self accesses the attributes of the current electric car. There is a battery that is a class battery that is, or an instance of a battery that is acting as an attribute to the electric car, and then that battery has its own attribute, or attributes and methods. And again, I just switched it from an attribute to a method right there at the end. But that's that was just kind of an example to show you that if there is a lot of information about a certain object, you may want to encapsulate that into a class, and that class could then still act as an attribute. So I feel like I lost some of you there. It is a Friday. I look out, see the eyes glazed over. But does anyone have any questions there? Let me find us one. Let's do one last thing. Just so we've done all of this work in main.py. How would you put this in another file and then call and make an electric car in main.py? So how would you move all of this to another file? Just think about that for a second, because I think we'll have the next project will have that thing. So how would you move all of this classes to another file?
Outside of just copying and pasting to another file?
We'll go in and do that, but then how would you use it in main?
Whatever you title it.
Yeah, go for it. That's what I'm asking. Just a little exercise. You want me to all do it? You're all looking at me like, so I would make a file called car.py. I would copy and paste all of this class information. Yes, that's what I was going for. And then how would you use all of that still in main.py? And I think that's what you were starting to tell me, Anna.
Do you want me to say it?
Let's give everyone a moment just to try it. I think you all know it. So Anna, how would you say it? You would do, or how would you access all of this if you moved it to another file?
From car, import car.
Yeah, so import car. We would also need electric car, but you would not need to import battery, because again, we're not actually trying to make a battery. The battery is just used by electric car. So that's just a little thing I wanted to review from last time. All right. Any questions on anything we talked today about inheritance? How about one more little challenge for the day, just to wrap us off? Right, so let's do one more thing with restaurant, and just to kind of keep a couple ideas fresh in your mind. So here's a little exercise to end us off. Write a method that adds an ice cream flavor to the flavors attribute in ice cream stand. So think about how would you do that? How would you write a method that allows you to add flavors to the flavors attribute in ice cream stand? All right. So it really is a pretty quick little exercise right there. We haven't dealt with lists much these last few days, so I just wanted to do an example where you had to append it to a list. We may be doing a little bit more with lists next week so I just wanted to get that as an example back in your mind. So I just added another method called add flavor, which takes as argument self and flavor, and then self.flavors.append whatever the flavor is. My personal favorite is cookie dough. So you can see before I add it, we have just those three, and after I add it, we have and call the flavors, the method that displays the flavors, it is also added to that. So that is object-oriented programming, classes, inheritance. Does anyone have any questions? Yeah.
For the car one, would you be able to import just electric car and be able to use it without grid?
Yeah.
Or even have to import car?
So yeah, let's go ahead and just verify that. So if I'm not making a car, and then if I need to get rid of that as well, then you can see it run that. Yep. What's all that? Line 64. It's bugging out. So yeah, see.
That's cool.
All right. Any other questions? Okay. If anyone has any questions concerning the next project or just anything in general, feel free to stick around. And if not, I'll talk to you all on Monday.